Hey, thanks for tuning in. Today we're going to learn how to convert decimal numbers to binary numbers. Suppose you're making a lasagna, and the recipe calls for it to be in the oven for 45 minutes. When you put the lasagna in the oven, you pull up a timer app on your phone and put in 45 minutes, hit go, and the timer starts counting down. But how does your smartphone know that 45 minutes that you typed in actually means the number 45? Smartphones don't have brains. To understand what this smartphone is doing in its calculation, let's first learn how binary code represents numbers. A binary code looks like this. It's a line of ones and zeros. I like to think of them as cubby holes though. So if we only have one cubby hole, we can only represent two values, empty or not empty. But if we have a second cubby hole, then we can represent four values. We can have empty and empty, empty and full, full and empty, or full and full. Add one more cubby hole and that makes 8 total combinations. If we follow this pattern, we realize that the number of values that we can represent is actually equal to 2 to the power of the number of cubby holes that we have.
-1.
For example, if we have 3 cubby holes, that's 2
to the second.
Or 4 cubby holes would be 2 to the third. So if we have n cubby holes, we have 2 to the power n.
-1.
If we draw each cubby hole with the number of values that that new cubby hole can represent above it, we realize that each new cubby hole that we add is actually the last number squared. So let's draw these out. If we have one cubby hole, it represents 2. If we have a second cubby hole, that represents 4. If we have a third cubby hole, that represents 8, and so on. And then what we actually do is we add 1 to the beginning to represent 0 and 1. We can start representing values by adding up the number above each cubby hole that's filled in. So let's start filling in certain cubby holes. If we fill in the first cubby hole, that represents 1. Then if we fill in the third cubby hole, that represents 4. So if we add those together, the whole number is 5. Therefore, filled, unfilled, filled represents the number 5. In binary code, filled represents a 1 and unfilled represents a 0. So in this example, the number 5, or filled, unfilled, filled, is actually equal to 1, 0, 1. Let's try another example. If we fill in the 5th cubby hole, the 4th cubby hole, and the 2nd cubby hole, then the number represented by these cubby holes is going to be 26. This method can be used for any positive real integer. In order to convert a decimal number to a binary though, it's easiest to think about filling these cubby holes from the left to the right. If the represented decimal number above that cubby hole is less than our target number, then what we're going to do is fill in that cubby hole and then subtract the represented number from our target number. In the case of our lasagna, if we type in 45 into our timer application, then the 45 is going to be saved in the smartphone as a binary number. So let's see how to do this. First, we'll draw enough cubby holes to cover our number, 45. Since we know that each represented number above our cubby holes is equal to 2 to the n, where
-1.
n is the position of that cubby hole, we can find the first cubby hole, which is greater than our target number, 45. In this case, we'll choose 7 cubby holes. 2 to the 6 is 64, which is greater than our number, 45. If we had chosen
5,
2 to the 5 is equal to 32, which is less than 45. Starting from the left, we fill in the cubby holes that are less than our target number, and then subtract the represented number from our target number. You cannot subtract 64 from 45, so we're not going to fill that cubby hole in, leaving it empty. The next number is 32. We are going to fill this cubby hole in because it's less than our target number, which is still 45. Then, we're going to subtract 32 from 45 to give us the next number, which is 13. The next cubby hole, which is 16, is greater than 13, so we're not going to fill this in. We're going to go to the next cubby hole. 8 is less than 13, so we are going to fill in this cubby hole and then subtract it, giving us 5. Next, 4 is less than 5, so we are going to fill in this cubby hole, and then subtract it, leaving us with just 1. The next cubby hole is 2. 2 is greater than 1, so we are not going to fill in this cubby hole. Finally, the last cubbyhole is 1. 1 is equal to our target number, which is 1, and you can subtract it, so we are going to fill in this cubbyhole, and then subtract 1 from 1, leaving us with 0. With no cubbyholes left, we're done with this calculation. Reading these cubbyholes as 1 being filled and 0 being unfilled, we read 0, 1, 0, 1, 1, 0, 1. Next, dropping the leading zeros, that being any 0 to the left of our number, of our first one, we get 1, 0, 1, 1, 0, 1. This number is then loaded into our smartphone's memory, and then our app begins counting down from that number. After 45 minutes, your lasagna is ready to be taken out of the oven and enjoyed.